So question F, we have here some leading coefficient f squared, which I've got over here. We've got our 2f as our middle term, and that's going to be generated by these two parts here and here, and then our constant term, which I've highlighted in green over here. Okay, so really the constraint on this problem is that the middle term has to add to 2f. Okay, and since it's plus, they're both going to be a positive sign. Okay, so this is a plus here, a plus here, so we're stuck with only two positives that can generate that 2f. So there's really not much choice here because we really need to get the 2f, we need 1 and 1. And if that's the case, our diagonal product that we're going to generate across this diagonal, okay, is got to be equal to 1. I'm just going to write down 1f squared. To get 1f squared, the only way that we can get 1f squared across this other diagonal here is if the blue square is going to be equal to 1, and this is equal to 1. That's the only way that we can get 1f squared. So the answer that we have here is the only choice we have is 1 and 1. Okay, we can only have 1f squared plus 2f plus 1, and that's going to generate the proper area. Now there is another way around this. However, this involves, well, kind of cheating, I guess, in that we could possibly get that 1f using a 2. Sorry, we can get that 2f using a 2 and a 0. If that's the case, our diagonal product is equal to 0. That means to get a diagonal product across this other diagonal, we need a 0 multiplier, and that makes this equal to 0. So then we end up with 1f squared times 2f. Okay, and in fact, actually, it doesn't have to be 1. This could actually be anything because our diagonal product is 0. This number in here could be 1, it could be 2. Okay, this number can be any number. So basically any integer. Now that's kind of cheating because we're using a 0 here and a 0 multiplier. So really the only real solution that we have is going to be if that's going to be 1 and 1, and then that will generate a polynomial that can be factored.